Example 1.6, electric potential. 2 point charges Q1 equal negative 40 microcoulomb and Q2 equal negative 30 microcoulomb are separated by a distance of 15 cm. Calculate A, the electric potential at point A, and describe the meaning of the answer. B, the electric potential at point B. Now, write down all the information given. I wrote down here, Q1 is negative 40 times 10 power of negative 6 coulomb. Q2 is negative 30 times 10 power of negative 6 coulomb. And here, we determine R1A. Where is your R1A? R1A is from point A to charge Q1. This is your R1A. And then R2A, we label it from point A to charge Q2. So your R1A, you have there 5 times 10 power of negative 2 meters. And then your R2A is 10 times 10 power of negative 2 meters. Okay, now, so we saw for part A. So for part A, we want the electric potential at point A. So you write down as this one. VA is V1A plus V2A. And then V1A, you use equation KQ1 over R1A. Okay, and then plus KQ2 over R2A. Next step is, of course, substitute value. So, substitute value, K you can put it outside. So, 9 times 10 power of 9 here. Okay. And then Q1 is negative 40. So, please take the negative sign because V is magnitude or scalar, quantity scalar, times 10 power of negative 6 over 5 times 10 power of negative 2, and then plus negative 30 times 10 power of negative 6 over 10 times 10 power of negative 2. And what do you have for your VA? You have negative 9.90 times 10 power of 6 volt. So, describe the meaning of the answer. So, 9 times 10, 9 times 9 times 10 power of 6 joule of work is done by the electric field in bringing 1 coulomb of positive charge from infinity to the point A. So, B, you can label it because you have a B, point B there. Okay, I label it here. So, R1B, here is your R1B, right? From charge Q1 to B. And then how about R2B? R2B from B2 charge, Q2 R2B. Okay, so R1B here you must calculate it using a theorem Pythagoras, and then while R2B is 13 cm. Okay, so R1B is square root 15 times 10 power of negative 2 squared plus 13 times 10 power of negative 2 squared. And what do you get? 19.9 times 10 power of negative 2 meters. So your R1B. R2B just now is 13 times 10 power of negative 2 meters. Okay. Your Q1 and Q2 is the same. Are the same. Sorry. Okay. Now, VB, you want VB, right? Electric potential at P, which is V1B, because you have two charges, so V1B and V2B. Okay, if you have more, then you have to add more. Then VB is K Q1 over R1B plus Q2 over R2B. So substitute value, which is 9 times 10 power of 9, and then you have negative 40 for Q1, negative 6. R1B 19.9 times 10 power of negative 2 plus negative 30 times 10 power of negative 6 divided by 13 times 10 power of negative 2. So your VB you will get negative 3.89 times 10 power of 6 volt.